So, okay, our topic for today is about tension member. But first, didalaan kita hit connection. Diba? Nayakan hira. Your structure is just as strong as its weakest link. And one of the part or link with the team structure is connection. Bisan pa tuhay-tuhayan dida maupayan imo material ang gingamit, bisan pa your member can sustain great loads, dagko nga load. Pero kaniyan connections between members weak hiya, diri hiya well designed. So, waray lang yapit itong gamit. Diba? Kaya mag-fail nga ni connection, ada kay failure na ito. Okay, so dedicated tension member, dedicated analysis of tension members, dedicated bolted and welded connection. Pero actually, bolted laan for today. Okay, so ano ba bolted connection? Nakikita niyo kaya nga here. Nakita niyo yung picture. Okay, so we have here a typical connection. Okay, di ba when these plates are subjected to a tensile load like this one, ano ba ito ways na mag-fail niya? So, there are many modes of failure na atong kukulawan. Okay, and una din is the yielding failure. Ano ba yielding failure? Ibig sabihin, ma-reach niya an FY, di ba? The yield strength of the material or of the, yes, the yield strength of the material. And number 2, the rupture. May dakita block shear. May dakita shearing failure of bolts. And of course, number 5 is the bearing failure of plates. Okay. So there are 5 nga itong nakikita. That's the mode of failure. And there are also types of design philosophy nga itong nakikita. We have number 1, the allowable strength design, and the load and resistance factor design. So ano ba pagkakaiba at allowable strength design? O allowable design, nagamit iniyahin factor of safety. So summary nga din what is the allowable stress? May dangani word na allowable, automatic it ginpapagamit ha imong design. Type of design philosophy is allowable strength design. And you have to use the factor of safety. Okay, for example, the capacity of the bolt, pananglitan lahat, the capacity of this material is say 100 megapascal, the capacity in terms of stress. Okay? As diri mo exasagad dit imo pag-design ito ng 100 megapascal because you need to see to it that even beyond the allowable, dapat an imo member can still sustain kasi diri ka maaram kung ano ito hinanabuha future. Diba? That's why may dakita factor of safety. It atong ginbubuhat, ginlo-lower nato it i-allowable. Say for example, the capacity is 100 megapascal. It atong gingagamit la ito ni sometimes lower than 100. Say for example, 70 megapascal. Para in case nga maghataas pa kit 70, safe pa. Basically, di ba? Iton the difference between kuan aton ang sinisiring na safe. Kumbaga amoy pinhiyaan ang sinisiring nga factor of safety naton. May pa parang sort of safety nets para kung sakali mga ma-reach iton or maglapos, at least kaya pa. Diri pa hiya automatic nga mag-fail. Kasi kung 100, pada kay bisan pa 100.1 nga 100.1 megapascal nga stress, mag-fail na itong yan. Di ba? Anything beyond. Okay, dili naman load resistance factor design. Kung allowable, nagamit yung factor of safety. Dili load and resistance factor design, nagamit kita yung reduction factor. Di ba? It reduction factor. Ang fee nga ni nakakanundong kamuhan. Fee, okay. Dili allowable, nagamit kitahan factor of safety. Di ba? Dili nagamit kitahan reduction factor. Di ba nakakanundong ka mo? If you have PU, to solve for PU, we just need to multiply the nominal force, Pn, by the reduction factor. Same with Mu. Mu is just equal to the reduction factor times Mn, the nominal, diba? O kung allowable strength design naman, Pa, the allowable, is equal to Pn, the nominal, divided by the factor of safety. Diba? And Ma, this is just equal to Mn, the nominal moment, divided by the factor of safety. So, amin tira pagkakaiba. So, allowable strength design, factor of safety yung nagagamit. Load and resistance factor design, yung gagamit natin is the reduction factor. Reduction factor. And also, nagamit kita dinihin, sinisiring natin factored load, di ba? Nakakanundong kapamuhan nasa ring nga 1.2 dead load plus 1.6 live load. Amon hiya din ini. Amon hiya iting gamit din load factor. Okay, load and resistance factor design. LRFD. Okay, that's the difference. Okay, so yun. Okay, let's focus here. Let's have an example. A lap splice connection shown above is made up of 6 mm by 150 mm plates. Assume diameter of hole is 3 mm bigger than the diameter of bolts. A minimum tensile strength, FU, so amit iya minimum tensile strength, or the ultimate, is equal to 552.93 megapascal. The allowable shear stress of bolt is 207 megapascal, and the allowable bearing stress is 1.2 FU. So we're talking about here the allowable bearing stress and plates, and that is 1.2 FU. FU is given, it's right here. And of course, the yield strength is equal to 449.25 megapascal. The diameter of the bolt is given, compute for the allowable value of P. Now question, ano nga type of design yung papagamit din? What do you think is the type of design natin papagamit?
ASD, sir.
Why? Kaya ano daw lang? Miss Gavan.
Kay allowable value, sir. Allowables one ko.
Diba?
Ginamit.
Okay ha? So meron nga ni find the allowable value P. ES dito. So meron nga ni nga find the ultimate value of P. Find the ultimate value of M. Find MU. LRF dito. So let's try to answer. Take note there are modes of failure. We have here yielding, rupture, block shear, shearing failure of bolts, bearing failure of plates. So tanan naton kukuanan. Tanan naton kikitaon. Di ba? Kay di pa pa-determine nga man kung ano ang value ng P. Pero usually the board exam nasa rin ito. Find the allowable value of P due to yielding. Find the allowable value of P due to rupture. Okay, pero dili nga na magyakan, tanan nimo i-check. Okay, then later mapili ka kung hain di mo strength or the allowable value. O due to yielding lang nakita. Ano ba sinasari nga yielding? Okay. Diba marang kita nga stress is equal to force over area. Diba? Siya una-una yung maging tutuduha iyo strength of materials. So rearranging this formula, we have force is equal to stress times area. Okay, so amo init aton kumbaga pinaka-basis it aton analysis. Force kasi yung bibilin, di ba? Value of P, and that ibig sabihin force is equal to stress times area. So kung nominal value, before you can solve for the allowable, of course you have to solve first for the nominal value. Then later, ikukuha mo ang iyang factor of safety. Okay? Pero later na ito, pag-apply yung factor of safety, kukuha lang natin ang nominal value of P before we can solve for the allowable value. Okay, so PN lang kukuhaon, that's the force. Yung stress nimo, since this is nayakan man the yielding, we are looking at the yielding failure. So atong gagamiton nga stress din is the yield strength, di ba? Yield strength of the material, Fy. Okay? Tapos ang gagamitin natin na area is AG. Take note, if we are using the yielding strength of the material, ibig sabihin the Fy, pero may ito niya gross area. Ano nga area itong gross area han aton plates? Okay? Perpendicular to the force P. Okay? Take note, your force and your area here are perpendicular to each other. Okay, and yung gagamitin ng Fy, yung gagamitin ng stress is Fy because we're looking at the yielding strength. Okay, so this is your formula. Now we have there given an IMO yield strength. It's right here for 49.25 megapascal. And your AG here. Okay, hanapit nga AG. Let's take a look at the this figure. Diba? Failure due to yielding ngani. Ibig sabihin nito, an IMO member mismo ang nag-fail. Nag-yield hiya. Okay? So, if this is your member, it nag-yield dito niya, dida hiya nakat. Diba? Nakikita niyo? Nakat hiya dida. So, ito na area is this area right here. Gets? O, ano ito niya nga area? That is Naman, kita niyo, the Laplace connection shown above is made up of 6 mm by 150 mm plates. So, amot hiya kada 6 by 500. Ay, 500 man. 150 man na didi. Nag-iba man. Tapos 500 didi. Okay, never mind ha. Basta base times height ito niya. Okay, 150 lang niya. 1,500 500 ang nabutang dida. 150 mm. So your AG therefore is equal to 900 mm squared. Oh, substitute ko. Ano na? Your PN therefore is equal to 404,320. PN pala ito nominal. Naya kan find the allowable value of P. We are in 2015, so kung allowable nga ng bibili, for 2001, 0.6 times PN. We already have the value of your PN. That's allowable mat din bibiling. Multiply line 0.6, then the result, that's your allowable strength. Okay? Allowable value of P, and that is 242.505 kilonewton. For 2015, kitaan this is 404,325 Newton over 1.67. Take note ha, this one right here is the factor of safety. Factor of safety is denoted by omega. I-try daw niyo it 1 over 1.67. What's the value of 1 over 1.67? Anyone?
0.5, sir.
0.5 talaga. 59.
0.5988023952.
Approximately 0.6. Mo na nga ito niya tiyada. Okay? So for 2001 and 2015, paring hulay tira. Actually, pare 2010 giha. 2010 and 2015 kasi parang magpaparihulay hira. Okay, so we're expecting the same value here, and that is 242.1 0.110 kilonewton. Okay, basically the same like niya. Okay, this difference is parang makikita man niyo dito choices. Okay, but since it aton choices, it aton exam, it aton quizzes, wala man choices, you have to use ano it gin-indicate. So meron nga 2001, 0.6 it gamita. So meron nga 2015, it gamita is 1.67 na factor of safety. Aton quizzes. Pero kung aton nakamuha board exam, don't worry kay bisan natin yung gamiton, same matitigo mo lang it answer. Dili man ito ron kakahera it are differences. Any questions so far? May pakiana? Anyone? Sige. Dili kita next. So for yielding, okay, for yielding an aton valuehan PA, the allowable value of P is equal to 242.110 kilonewton. Oh, sunod nga type of failure, rupture, di ba? Ano yung rupture? Take note, kanina ang yielding PN is equal to Fy times Ag. If y nga ating gagamit, yield strength natin gagamit, gross area at ating gagamit. Yield strength and the gross area pero magpadis. If you or the ultimate strength of the material, iya padis is AE or the effective area. Ano ba itong hiya? Diin ba itong hiya usually ninanaboy rupture? Explain ko lang muna. Okay, of course, your FU is given. That is 552.93 megapascal. Thus, we are looking for the value of AE. So, paano ba natin solve it AE? We have the formula for AE. We have AE is equal to U times AN. AN is the net area. Later, as we go on, i-explain ko kung ano yung AN. Ito nga net area. Kaya ano net area? Yadi, gross. Yadi, net. Kaya ano masisiring nga net? And what is U? Okay, sige. In a rupture, di ba? In a rupture failure, okay, it usually ito nila nga failure is aada dida hit kung hain di init kalinya niya dida hit tawag ini hit bolts, di ba? Dida nag-rupture, diri hit member, dida mismohan may mga bolts. So ada dida nabubutak. Nakita niyo? Then if we try to solve for the area, ito nga area. Ito nga net area is this area. excluding the area occupied by the bolt. That's why it's called net area. Kasi ginkuha mo na ang area ang ginoccupyan bolt. Nakuha? Hmm. Sige, that's the net area. And that is, if we try to, here, that would be, pera ba? Net area is 6. This is the width. 6 times 150. Gin-minus ko lang ang mga width or ang mga height ang mga buho. Take note, ang ating height and buho is 19. That's the diameter of the bolt. It's right here. Nakikita niyo? Tapos nayakan din the holes is 3 millimeter bigger than the diameter of the bolt. That's why it aton minus din is 19 plus 3. Duha ka 19 plus 3. Okay? 6 times 150 minus anyan hinga mga distances. Nakuha niyo? I hope nakukuha niyo it equation, it AN. Okay? An area la ito ni kaya na shade below. Take note la, it distance it, diameter han mga bolts, ang mga buhok dida is 19 plus 3. 3 millimeter bigger than the diameter of the bolt. Oh. AN therefore is equal to 636 mm squared. We still have the value of U. U is the shear lag factor. Okay, how do we solve for the shear lag factor? AE manit atong kinukuha, AE is equal to the shear lag factor times AN. Your AN is already solved, 636 mm. Dedicated shear lag factor. Shear lag factor U for bolted connection. Okay, damo yung ka-cases ha. Pero let's try to make sense of these cases. Number 1, when the tensile load is transmitted by bolts through all the cross-sectional elements of a member, U is equal to 1.0. Ano ibig sabihin ng cross-sectional elements? Okay. Suppose we have this members or elements. Members. Aton mga members amoy niya. May dakita plates, di ba plate ini? May dakita tawag ini angle, may dakita T, may dakita wide flange or I. Di ba? Mga members ini. Ano is ini serhira nga mga cross-sectional element? For the plate, prepared a cross-sectional element. 1. For the angle, there are 1, 2. There are 1, 2, 3. Usually, there are 5. There are 5 cross-sectional elements. Nayakan. When the tensile load is transmitted by bolts kay dedicated bolted connection, through all the cross-sectional elements of a member, U is 1.0. Ibig sabihin, tanan nga ni may bolt ng cross-sectional element, 1.0 din niya. Example, yan. Tanan may bolt. Ibig sabihin, the distribution of the load is all throughout all the cross-sectional element. Kasi there are cases kasi nga and may the bolt lock and later. May da ini another case. Basta ito niya. If the tensile load is transmitted by bolts all throughout the cross-sectional elements of a member, then U is 1.0. Okay, klaro. Dedicated number 2. May ngayon ng sample din. How about this one? Kita. This one, adila didi and may bolt. Didi waray. Ibig sabihin, and forces naging kikarryhin ni din ng element, didi mapapasa nga another element because waray man din bolts, di ba? So, didi 1.0. Nakuha. Okay. Dedicated number 2. W, M, S or HP shapes with flange width not less than 2/3 of the depth. The structural T's cut from these shapes provided that the connection is on the flanges. Take note, this is very important. The connection is on the flanges with at least 3 fasteners. It's either bolts or rivet per line in the direction of the load. Your U is equal to 0.9. Ano ba ibig sabihin niya? I think what you need to remember here is the ininga word. Connection is on the flanges. Tapos the flanges width is not less than 2/3 of the depth. No? Flanges is not less than 2/3 of the depth. Total depth itong niya. Ano ba ibig sabihin? Nakita niyo nga connection. Waray niya bolts didahan web. ang tanan nga connection diha diha flanges kita. It cross-sectional area, it cross-sectional view niya nasugad. Nakita niyo? Duduha nga wide flange section ginko connect hera using a plate abaw tapos may naman mga tawag ito mga bolts, mga rivets. Okay, waray ang connection, waray didahan web, didihan flanges. Nakita niyo Teddy? Okay. Nayakan, 3 fasteners per line. Okay. 1, 2, 3 per line. In the direction of the load, your U is equal to 0.9. Naintindihan? Daw with flanges at connection. Flange width is not less than 2/3 of the depth. Ano ito? 0.9. Hindi kita next. Wala, hindi na nadarat akong computer. What happened? Wala na daw dumara. Next. Okay. Okay. Dapat mga animation. 1, 2, 3. There are 3 fasteners. Okay, number 3. We have here, parang same lahira, pero basahan niya pagkakaiba niya. WMS or HP shapes with flange with less than 2/3 of the depth. O kita anya di, not less than, adi, less than na. And structural T's cut from this shape provided that the connection is on the flanges. On the flanges lagi ha, with at least 3 fasteners per line direction of the load. 0.85 with iya lag factor. Shear lag factor. At pagkakaiba nila number 1 and 2. Adila, di ba? 2/3. Adi, I mean, it nga number 2, not less than 2/3. Didi, less than 2/3 na. 0.85. Di ba? Okay. Number 4. WMS or HP shapes provided the connection is on the web with at least 4, take note, hiya ha web ha, waray na kuan nga 2/3 or whatever, basta iya connection ha web with at least 4 fasteners per line in the direction of the load, your U is equal to 0.7. The shear lag factor. Okay? So, galing there are 4 bolts. Number 5. Single angles with at least 4 fasteners per line in the direction of the load, your U is equal to 0.80. For single angles with 2 or 3 fasteners per line in the direction of the load, at pagkakaibit number 5 and 6, at a single angle with at least 4 fasteners per line in the direction of the load. Diba? Single angle with at least 2 or 3 fasteners per line in the direction of the load, 0.6. Adi 4, adi 2 or 3. Okay. Then may napakita another one. Okay. Inihiya din this is just parang ano ba tawag ini? I forgot the name. Okay, kasi you can also solve the shear lag factor using this formula. U is equal to 1 minus x bar over L. Okay, all tension members except plates and HSS, take note, all tension members except plates and HSS, where the tension load is transmitted to some but not all of the cross-sectional elements by fastener or welds. Okay? Kasi number 1, tanan nga cross-sectional elements may bolts. So 1.0. Kasi even man it distribution hand load. Dinhi, tension load is transmitted to some but not all of the cross-sectional elements. So yun mo ma-reduce. Ma-reduce siya by this amount. X bar over L. Ano ba nga X bar over L? Okay, X bar over L, X is the connection eccentricity. So for example, for this connection between what's this angle and the plate. Okay, your plate kasi anin it iya centroid, di ba? It angle, as it iya centroid. The distance from the centroid to the face nga nagko-connect. Okay, nagko-connect na face didahan between the plates and the angle. Itong here connection eccentricity. Okay? So for C, this is the connection eccentricity. Another one, if you have this one, high mandate connection eccentricity. Diba the centroid is here? Amit centroid niya. High mandate connection eccentricity. Madi. Okay? Di dahit ko diri didit face nga nagduduot an eye nga hand plate. Di kan didahan centroid hand eye kutog madidan outer face hand plate. That's the connection eccentricity. Didi ada di dahit ang nagduduot nga face hand plates nga hand C or L. Okay? Kasi ito na sinis nga connection eccentricity. For this one, this is your oops. This is your centroid. It imo connection eccentricity. Kita ha? For I, this your connection eccentricity is taken din ang centroid han katunga la. Ako ha? Ang katunga la diri han centroid han bugos nga I. Ang centroid han katunga nga I kutob madto didtohan face kun hain nagduduot an I nga hand plates. That's your connection eccentricity. Okay. So yun. That's how you solve for the value of the U. L here is the length of the connection. Ano ko pa ngayon discuss an L. So ano itong length of the connection? This one. This is the length of the connection. So take kanila hit first bolt hand line, hand single line, kutob madtuhan last bolt. So that's the L, the length of the connection. Yan. What do you think is a value for you? Sige daw. Based sa itong mga gin-explain.
1, sir.
Very good. Kasi all member, may da bolts. All cross-sectional elements, may da man bolts. Diba? Diri man hiya I, diri man hiya H. Diri applicable 1 and 2. Diri man hiya L. Diri applicable and 5 and 6. Diba? So 1 here, your U is equal to 1.0. So when you solve for the value of the effective area, that would be 636 mm squared. Any question? May pakiana? Baray. Sige. Substitute. Then you will have P is equal to 363.48 Newton. That would be your nominal force. Nominal tensile force. Take note, this is nominal pa lang. Ipapabili nga is the allowable. 2010. 2010. Okay, we are on the rupture ha. Ada kita rupture. For 2010, your P is equal to 0.5. Take note ha. Liwat-liwat. Yielding, for 2001, 0.6. Okay, surat ko na lang ha. High yielding, surat ko dili para matigam na niyo. High yielding, an iya PA is equal to 0.6 Fy times ano to? Area, gross. Di ba? Didi rupture, an iya PA is equal to 0.5 Fu times AE. Okay, nakita niyo? Nakikita ba niyo? Ipagkakaiba nila. Tigam niyo ha. Kita 2001 ha. PA is equal to 0.5. Your PN is equal to Fu times AE. Amin yan rupture. Unyielding yadi. Okay? Okay. So, when you substitute the value of PN, you will get PA is equal to 175.832 kilonewton. 2015. P is equal to the value of your PN, which is 351,663.48, divided by the factor of safety. Okay, ano ang pagkakaiba again ng yielding and rupture? Yielding and a factor of safety is 1.67. Rupture, the factor of safety is 2.0. So the result will be 175,832. Di ba parang nagpapareho lahera? Because 1/2, this is the factor of safety. 1/2 is 0.5. Parang nagpapareho lahera. Okay? So let's take 175.832 kilonewton. That's the value for PA if we are looking for the rupture. Okay. Next, we have here the block shear. Ano ba yung block shear? Okay. Now, there are different ways. Medyo makuha-kuha ni block shear. Okay. There are many paths anuhan pag fail in terms of block shear. Explain natin. Okay, una, this one. Can you see it? Okay. For this one, bangin yadaan makuan block shear. Ano ba ibig sabihin? Explain ko lang yung block shear. Diba? From the word itself, block. Parang may da block na makukuha. Diba? Kaya ano may shear? Kasi some of the part na nakuha nga block, nag-shear hiya. Okay, example this one. Kumbaga, ang nakuha nga chunk or nakuha nga block is this one. Diba? May daman it force didi. Kumbaga, diba, this is your member. Kumbaga, nakuha ini nga chunk or nakuha ini nga block. So, ini, makukuha na parang mag-fail na. Di ba, mararatas ba ini nga member nga di? Kasi I'll explain. Mararatas anyan nga member kasi yun nga nag-share off anyan tas nakuha ini nga block shear, di ba? Ini makukuha nga di. So sa ito niya nga path and block shear failure. Another path is this one. Okay? Pwede anyan nga block and makuha. So nag-share off din nag-share off din tas nakuha ini nga block. Okay? How about this one? Is this possible? Is this possible have block shear? Nakuha niya nga block, tapos adin makukuha. Okay? The answer to that question is no, because may da pa bolt din nga ma-counter hand force nga naka-apply ti pakadi. Diba? May da pa man bolt din Okay? So dire pa hiya totally failure. Okay? So when you are looking for the block shear failure, this will not be possible. Kasi may da pa bolt na nakakaanohan niya. Nagigets ba? May da pa na-counter nila nga bolt. Okay. So duduhit atong gikikitaan din Ano pa ba? May da pa ba iba? Pwede kasi gihap nga instead nga adi haubos at habaw-baw. Pero pareho lang nga itong hera. Di ba? Okay, balik-balik kita nga dito. Okay, di ba an ilaram an nakuha? Possible pa sigihap nga it makuha and tikan oops. Possible kasi an makuha tikan din adto. Adian makuha, di ba? Pero sing lang ako itong herityada. Mag-iba lang ang orientation. So, itatang pagkikitaan ini nga duduha. Okay. Just explain ko na ngayon dito. Okay, ritatan ko kitaan. Una niya laalanay. Ano ba ito nga block shear? Dilit block shear, duduha nga type of shear stress it imong gikita. Okay? Kasi, take note, the force is directed pa kadi. Okay, this area here, kita niyo, may daan explanation dito. Hindi ko may animation. Okay, this is the formula for block shear. Take note, Fu, Pn is equal to 0.6 Fu, ENV, and V. Ano V, di ba? Shear area of the shear. ENV, net area of the shear. Kumbaga, an area subjected to shear. ANV. Net area because you have to subtract the holes of the spaces occupied by the bolts. Okay, shear here. Plus UBS FU times ENT. Ano ENT? ENT is the net area in tension. Okay? UBS, that's the ano to UB? May that explanation later. Okay. So this should be lesser than or equal 0.6 FY AGV UBS FUANT. Diba? Nakikita niyo. Pareho malainit yan Diba? Pareho lahera. A and B is the net area subject to shear. Net area subject to shear. A and T is the net area subject to tension. AGV is the gross area subject to shear. Gross area, ibig sabihin, hindi rin natin ima-minus ang mga area occupied by the bolts. Okay? Net area has shear. Kaya ano shear hiya? Kasi di ba aton force na sugad? It yan nga area parallel hiya, hanyan hinga force. Shear area nga, di ba? The the force and the area are parallel to each other. A and B. A and T naman is this area. Makita niyo? Kasi ito nga area is perpendicular to the applied force. Okay? Net area subject to tension. Alright. Meron nga yung mga arrow-arrow pa. Okay, so amit hiya. Let's try to solve for A and B. A and B is equal to, kita daw niyo at A and B. Adi ha, net area for shear, ini nga yellow. That would be 6. That's the width, di ba? 6 multiplied by whatever is the net length. And that is 75 plus 90 tas minus usang hinto nga buho. Di ba? 75 plus 90 minus usang hinto nga buho. 22. Kaya 22. 19 man la didi. Ay 3 millimeter bigger daw ang diameter of the hose, di ba? The diameter of the bolt is 19 and hose is 3 millimeter bigger than the diameter of the bolt. That's why 23. Kaya ano 1.5 kita daw? 1 whole diameter tapos didi radius. 1.5 of the diameter. So this is your A and B. And the result for A and B is 792 mm squared. Let me substitute it there. Sunod naman is A and T. A and T is the area in tension, net area in tension. This one. Okay? Same balat iya with 6 mm gihap. Okay? Multiplied by the net height, and that is 90 plus 30. Okay, 90 plus 30 adi man. Minus pera nga buho. Usa nga hinto nga buho. 22. And the result is 522. 522. Okay. Then, hindi kita AGV. Gross area. Ito, gross area, ibig sabihin, hindi rin natin igma minus and buho. Kay gross man. Diba? Gross area of the shear. Okay, hanidaan shear again. Diba, amit yan to. Nakita nyo dito nga black. Hindi rin natin igbo minus ikuan. Okay, nakita nyo dito. Hindi rin nyo iba minus an areahan ko kay gross man. 6 times 90 times 75, the result is 390 mm squared. Okay. So this is the result. I think, careful lang ka mo. I think this is 0.6. 0.5. Because FU kasi ang gigamit. Sa'yo pa na kung kain code. Okay. FU is given, FY is given, and UBS is equal to 1. What is UBS? UBS for most cases except if tension is non-uniform. Uniform hiya kay plate hiya, di ba? If tension is non-uniform, UBS is equal to 0.5. For most cases, that is 1.0. Saan ba nagkakamiadahin ng uniform tension? Okay, nagkakamiadahin ng uniform tension if amo na adto diri nga ni tanan nga member cross-sectional element, diba? Ang cross-sectional element, for example, an webla and may da bolts. Ibig sabihin, mostly han mga tension aadto dito kaya ato man et na kukuan, ato may tagpupugong. Diba? Ha flange man la. O ibig sabihin nga dihan web. Hiya in terms of tension. So they're evenly distributed and forces. So they're nga ni evenly distributed. If the tension is non-uniform, then UBS is equal to 0.5. Okay, but since this is a plate, 1.0, UBS is 1.0. So the result is that one. Substitute everything there. The result will be, sige daw, what's the value of this one? Try to, I think this is 0.5 talaga. Pero kung 0.5, 5075 dinhi. Okay. So didi, asya na 555483. Let me try to verify that one. Sige daw. Bother ako. Okay. Wait lang. I-record ko again.
Sir, habok 0.6.
0.6. 0.6 talaga
Yes.
ngayon.
Tsaka
Madaling,
iba po nga kuan
kang
basta
kanay bukit yung maging gagamit.
kuan sir an ang tutorial sir may nakapag may na basis an pero wala po makabili.
Okay. Ayun na ha, wait lang. Let me try to verify that. Tama na, 0.6 talaga. Can you see this? 0.6 ANV and AGV. 0.6 talaga. Okay. Let's use 0.6. Okay, so amo na 0.6 there is 0.5. Okay, so the result is nayakamala. This is your PN, but this should be lesser than or equal to this one, 555. What if what if mas dako an PN kaysa niya nga quantity? It mag-prevail is this one kasi it should not be greater than this one. Yung mo gagamiton is 555,483.96 kung mas dakuan yan. So, okay. So, i-consider natin ang PN. 551,381.796 Newton. Take note, this is 0.6 ha. So, PN is equal to 551.382 kilonewton. That is in kilonewton. Okay. Ang nag-ibig natin is allowable. Okay. PA is equal to PN over the factor of safety. Omega is just the factor of safety. And that is equal to 2. Okay. PA therefore is equal to 275.691 kilonewton. Okay. Any question? May da pa kaya na? Okay. Di ba FU ang natong gingamit didi? Mga FU. Omega naton is 2. Okay. So the result is 275.691. Pero di repeto niya answer. Ay, ini nga 275.691 if amo niyan block nga nawara nga nakuha. Okay, what if this one it kung suga din it iteration, di ba? Just so muna naman. Take note, these forces right here, ito ng stresses, shear stresses ito niya. So adi ito niya nga yellow, di ba king color coded ko. As adi naman amitiyaan ka ng tension, the blue. Reaction, they are oppositely directed but they are the same magnitude. Okay. Now let's talk about the areas. Okay. So A and V, that would be 2 times 6. Kaya 2 times 6? Kaya may 2? Kaya duduhan na. Ay laro ngayon na baw-baw. Times 6, that's the width, times the net length niya. Kumbaga kung length man ito. And that would be 75 plus 90 minus duha nga 1.5 times 22. Usangan ito nga 22 millimeter diameter. And the result will be 1584 mm squared. This is the value for A and B. Okay? So, 1584. That's the result. That's the value for A and B, the net area for shear. Next naman is A and T, the net area for tension, or the blue one. So there you have there 6. Tapos ang yung width naman is 90 minus half dito, half nga di, usa na itong hiya nga buho, 22 mm. Okay? And the result is 408 mm squared. Okay. Then the AGV. Okay, gross area in shear. 2 kay duduha, di ba? Duduha nga area. Habaw-baw ngay na ilarong. And 90 plus 75. Okay, wala natin 8 minus ang buho kay gross area pa. 1980 mm squared. Substitute. Okay, next. Your FU is given, your FY is given, your UBS is equal to 1. So, solving the value, solve mo nga ni, the result will be For PN, that is 751,100.112 Newton. And this should be lesser than or equal to 759,304.44 Newton. So, lesser than man niya, so okay. Di ba? So, ititik natin ang PN equal to 751,100.112 Newton. This is not yet the answer because we still need to solve for PA. PN therefore is equal to, PA therefore is equal to 375.55 kilonewton. And this is the final answer for this instance. Okay? Take note, may nakita kanina pa. Ano itong kanina? Yan, hindi ba? Oh. Kaya ba aton i-take? Kaya it mas vulnerable. Kaya it mas vulnerable. Di ba, Yedi? Because it kaya lang niya nga i-sustain nga alaw nga P, adi man it P, it iyala kaya nga P is 275. Ibig sabihin, maggubiyan nga niya, marapatas na talaga it yan. Di ba, mag-fail na talaga hiya. Anya diyan niya, capacity is 375. Yun. Okay, so we will take 275.691 kilonewton. Lock shear stress. Okay? Okay, dili kita hit shearing failure of bolts. O yan na, bolts naman ito atong ginbibiling. Ginkikita. Nangyayon the allowable shear stress of bolt is 207 megapascal. So, ini nga shear failure of bolts, nag-shear off an imo bolts. So, pananglitan, makusog-kusugan ang imo member. Taka and weak ngayon is an bolts. Kay pareho lang nga how ito. Shearing failure of bolts, nag-shear off and bolts. Okay, paano man? Diba? Stress is equal to force over area again. Your PA, that's the force ang bibiling, the allowable. Your FV is the shear failure, the shear stress, or the the shear strength of the bolts. And that is given, di ba? 207 times AB. Ano man nga area? There are 4 bolts. Times pi over 4 times the diameter of the bolts. Diba? Diameter of the bolts is 19. The result is this one. 234,761.79 Newton. Any question? May pakiana? Okay. Kung kikita nga natin ni shear failure of bolts, there is to net result allowable. Waray na niya factor of safety and all. Nako ha? Any question? May pakiana? Naintindihan ba? It's shear failure of bolts. Kung kay ano 4 times pi over 4, kung kay ano anyan hinga area na itong gingamit. Diba? Ano nga area iton? And that area is parallel to the force applied. That's why it's called shearing. Because shearing nga ni permit area nga force parallel to each other. Okay? Kumbaga, ano ba itsurit nag-shear off nga kuan? Nag-shear off nga bolt. Parang nasugad. Oops. Balik ko man. So, mag-tweet mo force. Is na rin mo force. May na mo bolt dida, nag-shear off na nga ni, parang nagsugad na. Nag-shear off na hiya. Parang di rin na mag-align. Kasi nautod na hiya, nag-shear off na. An area din ini nga area is parallel to this force. And that area is the area of the cross-sectional area of the bolts, which is circle. That's why pi over 4 this word. Okay, there are 4 bolts man. So, upat. Okay? Na-gets ba? Okay, sige. It's the value for PA. Bili kita bearing failure of plates. Ang bearing failure. Example bearing failure parang nasugad. Hatap view. This is the force. Parang this is your bolt. Darakada ko di parang nagisi na hiya parang nagits niyo parang pag-explain parang papel nga gibuho atas nagisi na because of bearing failure. Parang ganun yun. Anyways. So, ano man imo stress gagamiton? Ada kay adiman. Okay, this is denoted by FP. Bearing stress, FP. And that is equal to 1.2 FU. Okay, let me erase this one. And that is, of course, there's is equal to force over area. Your force here is PA. Your stress is FP. Okay, FP is 1.2 FU. Hmm. That add formula. Diba? FP is equal to 1. Ano man, given man dili. The allowable bearing stress is 1.2 FU. Substituting the value, there are 4 bolts. Question, ano area nga itong gagamiton? Sige daw. Ano nga?
Thickness,
Ano?
thickness plate, thickness ng plate tapos
Multiplied by,
diameter hand bolt.
ano?
Thickness ng plate multiplied by the diameter hand bolt.
Very good. Thickness and plate multiplied by the diameter of the bolt. Kung bagay mo nga na yung i-project, diba? Yadi ha, didi kita. I-project mo nga na ini nga di. Didi na kinikita it yellow. Kinikita ba it yellow? Black. Yung nga na yung i-project nga di, and niya projected nga area di da. Ano na? Ano ko ba yun ko? Niya project, ini nga area. And that is equal to the thickness of the plate, di ba? Thickness of the plate times the diameter of the bolt. Ito nga area. Dadi nga area. Unprojected. So that is the thickness of the the thickness of the plate multiplied by the diameter of the bolt. Since there are 4 bolts, multiplied by 4. And that would be terabyte here. 302,563.296 Newton, or that is 302.56 kilonewton. This is due to the bearing failure of plates. Any question? May pakiana? Okay, if that's the case, how man aton answer the allowable value of T? What would be your answer?
Rupture.
Rupture.
17.88.
The result is 175.8. So, vulnerable here to rupture, di ba? So, dapat ada light imo limiting value of force, allowable value of T. Dapat diri na ma-exceed. Okay. Now, diin ba natin makikita ini nga mga kuan? Diin ba natin makikita nga mga tensile tensile member or structural member subjected to tension. Usually, di din nakikita may dahil hindi dahil trusses. Nakaka-concatenate, di ba? Dili trusses, the connection between trusses, between member of trusses. Pero dili tidak nakikita. May dapat tayo ba nakikita diha? So, tapos may member didi. Tapos may naman, may plates, di ba, nang ibubutang? Diba? Siya ba? Tapos, I'm sorry. That plates. Tapos may pa didi. Tapos may naman mga bolts dida. Whatever. Tsaka drawing. Okay. So, mga tension member ito niya. May mga tension. Iba ito nila ang member is subjected to tension. Ganun. Any question so far? May pakiana? Masahin lang, no? I think, amulit ko to bloody that akon ko. For now. Wait lang. Keep natin. Any question? May pakiana? Yes.
Sir, always po ba, sir, given po pag quiz event ko ang diameter of holes?
No. May dayton provision. I think 1.2. The hole is always 1.2 or 1.8. Hindi nga ngalimot ako. 1.8 bigger than the diameter of the bolts. I forgot the Okay. Pero in case it aton quizzes, in case it aton quizzes, ihahatag ko it diameter it hose. Okay? Pero,
What is, sir, ang properties po ng steel?
come again?
Like, ang properties po ng steel, like, ano yung FU?
Properties and steel. Usually, nasa rin man ito niya A36. Okay. Usually, nayakan ito nga A36. If the steel is A36, if this is A36, your Fy is always 248 unless otherwise stated by the problem. Your Fu is always 400 megapascal unless otherwise stated by the problem. So summary lang ani the member is made up from an E36 steel. Automatic na. E is equal to 200 gigapascal. Ano pa? Take mo lang here. Fy, Fu, and E. Pero usually ginahatag man ito. Actually, board exam, pati it provision, ginahatag. Kaya it mga formula, ihahatag yap ito ha board exam. Pero, dili pa man kita board exam. You have to memorize. Okay.